Welcome back. Let's talk a little bit about how you can separate mixtures back into their components. So the first technique I want to talk about is called filtration. And in filtration, we're usually trying to separate a mixture that has an aqueous layer, a water-based layer, and a more solid layer. And you pour your mixture through this funnel here, and it passes through the paper. And the paper actually has little tiny holes in it. Okay, they're so small you can't see them. But what happens is often the aqueous layer will pass through and the more solid stuff will stay on top. We call that aqueous layer that then passes through the filtrate. You can imagine this might be good for like sand and water. Distillation is more common in the organic chemistry lab, but in distillation we have a setup looking like this. This is good to separate two or more liquids because we're going to separate them based on the boiling point. So you put the two liquids in this round bottom flask here. It's called a round bottom flask because it has a round bottom. You place them in there and you slowly start to heat these liquids. What happens is the first liquid that has a lower boiling point starts to boil first, and it travels up here and it wants to escape here, but it can't because of the stopper. So it passes through this tube. And then this is a tube that has like an inner tube and then an outer tube filled with cold water. As the vapor passes through it with the cold water surrounding it but not touching it, it re-liquefies. And it then passes through here and you can collect it in this receiving flask. If you're heating slowly enough, all of your first liquid, maybe ethanol, will pass through first. And then there'll be a period where nothing is boiling. But then your second substance, the water, can boil. And the water will do the same thing. It will pass up here, it will cool down, and then you can collect that in your flask. And then you'll have two separate receiving flasks. You switch them during the time when nothing was boiling, and you have separated your ethanol from your water. Crystallization is when you evaporate part of a mixture and then the rest of the mixture solidifies. So if you think of salt water, and we'll actually do this in the lab, the water can evaporate or boil off and it leaves the salt remaining. And while you initially might not be able to see the salt because it's dissolved in the water, once you remove the water, the crystals form. This is the same idea of making rock candy if you've ever made rock candy. Chromatography can be used to separate substances based on particle affinity or their attraction to another substance. You saw this in biology perhaps with the spinach leaf, where you're able to separate the spinach leaf into the different pigments that made it up. This one here is based on color, right? So what you do is you have some liquid in the bottom here, and you put your maybe different colored markers, a dot in each of the spots here where I have the mouse, right? And what happens is the water travels up this paper, it carries some of the dot with it, right? But the dot also kind of wants to stay on the paper. So depending on the attraction to the paper and the attraction to the water, the dots move up different heights, okay? And that's kind of the general idea of chromatography. What is the mixture we're actually separating here? It's the different colored markers that we put on the bottom here. And those are the four common techniques that we'll encounter to separate a mixture.